All right, let's jump right in. Today, we are talking about a massive upgrade for all those complex systems that basically run our world. Think manufacturing plants, the power grid, you name it. We're talking about giving these systems a new kind of brain, one that can actually learn, adapt, and evolve on its own.
So let me just start with this question. What if all the systems we rely on every single day could do more than just follow a rigid set of instructions? I mean, what if they could learn from experience, predict problems before they even happen, and optimize themselves, like right now, in real time? That's the crazy powerful idea we're going to unpack today.
Okay, so to really get why we need this big of a change, we first have to look at why the old ways are, well, they're just not cutting it anymore. It's a classic case of trying to use old tools to solve brand new, incredibly complicated problems.
At its heart, system analysis is really just our way of understanding how stuff works. Doesn't matter if it's a factory floor or the stock market, we build these models to figure out how all the different pieces interact and to try and predict what's going to happen next. It's been the bedrock of modern engineering for a long, long time.
And this slide right here perfectly lays out the central conflict. The traditional approach, it's like using a hand-drawn paper map. It's based on a bunch of fixed assumptions, it's totally rigid. But modern systems, they're like a crazy busy city with constant construction and traffic jams. They're unpredictable and they generate just mountains of data. You don't need a paper map for that, right? You need a live, adaptive GPS. And that is the exact gap machine learning is here to fill.
Which brings us to the solution, machine learning. And let me be clear, this isn't just a small step forward. It's a completely different way of thinking about how we approach system analysis. Let's see how it works. See, the really crucial thing to understand is that machine learning is basically built for the chaos of the real world. It actually thrives on those huge, messy data sets that would totally crash the older models. It doesn't need us to spell out all the rules for it. It's designed to learn all the complex, hidden relationships all by itself. And this table kind of lays out the toolbox we're working with here. ML comes in a few key flavors. So first, you've got supervised learning. Think of it like teaching a kid with flashcards. You show the model a ton of labeled examples, like pictures of perfect products and defective ones, until it can spot a defect all on its own. Then there's unsupervised learning. That's where you just give the model a mountain of data and say, hey, go find some interesting patterns in here, like grouping similar machines on a factory floor to make things more efficient. And finally, you have reinforcement learning, which is all about learning from trial and error. Kind of like an AI learning how to control a robot by getting rewards for good moves and penalties for bad ones. So why are we going through all this trouble? Well, the benefits are pretty transformative. We're getting systems that are way more precise and can adapt on a dime. We're cutting down on human bias, and we're finally unlocking true automation and predictive control. This is the engine for what people are calling Industry 4.0, that next big industrial revolution that's being driven by smart, connected tech. Okay, this all sounds pretty cool in theory, but where is it actually happening? Let's do a quick run-through of a few examples of how this is already building a smarter world around us. In manufacturing, instead of waiting for a critical machine to break down, ML models can actually listen to the machine's vibrations and analyze its performance data to predict a failure before it happens. This saves an unbelievable amount of time and money.
Over in the energy sector, ML is what makes a smart grid smart. It's looking at weather patterns, how much power we're all using, and how much is being generated, all in real time to perfectly balance the supply. This is how you prevent blackouts and cut down on waste.
In healthcare, and this is amazing, machine learning algorithms can analyze medical images and patient data to spot the signs of diseases like cancer, often far earlier and even more accurately than the human eye. This has the potential to save countless lives. And in transportation, this stuff is the brain behind the logistics that gets your packages to your door on time. It is constantly calculating the most efficient routes for delivery trucks, taking into account traffic, weather, and thousands of other little details. So, the potential is obviously huge, but how do we actually make this happen? And, what's stopping us from putting this everywhere right now? Let's take a look at the path forward. So, this is pretty much the roadmap. It all kicks off with data. You need tons of it. And it has to be good, clean data. Then you train your model on that data until it gets really good at making predictions. Now, critically, you don't just set it loose. You test it over and over in simulations to make absolutely sure it behaves the way you expect. Only then, when you're confident, do you deploy it into the live system to start making real-time decisions.
Of course, it is definitely not always a smooth road. The biggest challenge, honestly, is often the data itself. You know the saying, garbage in, garbage out? And sometimes the models get so complex they become what's called a black box, which means we can see it's getting the right answer, but we can't easily understand why it made that decision, and that can be a little risky in high-stakes situations. Plus, you've got really high computing costs and the very real headache of plugging this new tech into older legacy systems. But even with all those challenges, this statement really just nails the whole thing. We are moving away from static blueprints and toward living, learning systems. Machine learning isn't just another tool. It is a fundamental change in how we analyze, understand, and ultimately control our world. It's absolutely essential. So I'll leave you with this. We have built the tools that allow our systems to learn. The only real question left is, what do we want to teach them next? What's the next great challenge, whether it's climate change or curing diseases, that we can finally tackle with this new intelligent approach? The possibilities are just getting started. Thanks for watching.